The severity and frequency of wildfire events have been increasing around the world, along with their impact on human lives, nature, and property. Although these headlines are frightening, fire is a natural phenomenon and has always been a part of many ecosystems. Many indigenous and pastoral communities developed valuable fire management knowledge and practices to safely coexist with fire.
Urbanization, climate change, and the fire suppression emphasis in fire management policy and tactics are all significant contributors to the worsening of wildfires and consequences in Europe. Southern European countries have been dealing with severe wildfires for decades, and less prepared Northern European countries have more recently started to experience larger and more frequent wildfires.
We are 3 of the 15 PhD candidates within the large PyroLife Innovative Training Network, a research group focused on developing integrated fire management strategies in Europe.
By managing landscapes and potential fire fuel, the risk of catastrophic wildfire consequences can be reduced, creating fire-resilient communities and environments.
The NFA developed FireWise program to adapt scientific findings to create fire-resilient communities across the US.
Fire scientist Jack Cohen defined the home ignition zone, the area up to 60 meters around the home. The conditions of this area define the survivability of the home. The home ignition zone is divided into 3 subzones: the immediate zone, the intermediate zone, and the extended zone.
My PhD focuses on the immediate zone and on providing practical recommendations to protect homes from the wildfire threats of heat, embers, and smoke. Valuable research in this field has identified the building components which most often lead to ignition. I will be focusing on the typical building materials and features of rural European homes to provide recommendations for the European wild-and-urban interface. I will be analyzing data to identify the most significant components and materials, and I will use computer modeling and laboratory experiments to investigate their role in building ignitions under different conditions.
My name is Nemer. I will be focusing on the wheat vegetation and home ignition zone. My PhD is based in Rhea, Aix-en-Provence, the south of France. I will be studying the flammability of the ornamental vegetation as well as their spatial distribution using fire risk-oriented GIS tool WEMAP for different study cases in France and Netherlands. I will be using the flammability data of the ornamental vegetation and near structural organic fuels to develop a fire propagation modeling for different scenarios that will help to understand the role of the ornamental vegetation in the fire spreading from the wildfires. I will be using the SNWFDS as a CFD tool and to validate the results with bushfire damage assessment. Eventually, I will be conducting a house-scale fire experiment at Corsica University, and my studies will help to design guidelines for fire-resilient landscape.
My PhD focuses on the design of fire-resilient landscapes, including the extended zone at Wageningen University in the Netherlands. Learning from communities and forest managers from Spain and the UK, I will work on developing landscape architecture solutions to mitigate the damage from wildfires while promoting beneficial fire traits in order to help create ecologies, cultures, and settlements that live and thrive with fire. My PhD will also study successful Dutch water management techniques to adapt them for fire resilience.